Hello friends, today I am going to discuss the production or origin of X-rays. The first part, that is continuous X-rays. We are well aware about the term X-rays, and last time I have discussed about how X-rays were discovered. It was discovered by the scientist Röntgen, and after that it was concluded that whenever fast moving electrons collide with a target material of high melting point and high atomic number, X-rays are produced. High melting point is required because 90% of the electrons will make the target material ready to produce X-rays. But exactly what happens after collision? Let us discuss it. Now, X-rays are produced with the help of a Coolidge tube. Now here you can see that there is a cathode and electrons will travel from cathode with the help of potential difference. Now here the potential difference is very high, that is approximately 10 kilovolts, 10,000 volts to 30,000 volts to 20,000 volts. So very high potential difference is applied, and under the influence of this high potential difference, electrons will move and will strike the target material, and after the striking of target material, X-rays are produced. And because very high heat is also produced, so water is circulated in the system in the Coolidge tube. So this is the basic working of Coolidge tube. Now again let us discuss what happened after the production, after the collision of electrons, with the target material, so that X-rays will be produced. Here you can see that X-rays are produced. So let us discuss it. Now fast moving electrons, many electrons will collide with the target material. Now after collision with the target material, the speed of the electrons will be reduced. Now let us assume that there is a very big magnet. And we will throw an iron piece towards it. So iron piece will not go straight, it will be deflected towards the magnet. Therefore the speed of the electron piece will be reduced. It means that the iron piece will be retarded, deaccelerated. So this same thing happened in this case, that electrons will travel, the primary electrons, the fast moving electrons will travel, and after passing through the atom, the target material, it will be attracted or deflected towards the heavy nucleus, the positively charged nucleus. So like this, the electron will travel, and after this there will be retardation of electrons. So according to the classical physics, whenever there will be retardation of electrons, radiations are emitted. This is also known as bremsstrahlung. Brems means to break and Strahlung means radiation. So it is known as breaking or retarding radiation or continuum X-rays. Now why X-rays? In this case, the radiation emitted will have energy equal to the energy of X-rays. So this is the main reason of production of continuous X-rays, that is retardation of electrons. Now suppose that V1 is the initial velocity of electrons. Half mv1 square is the initial kinetic energy of electrons. v2 is the final velocity of electrons after collision, and half mv2 square is the final kinetic energy of electrons. So v1 is the initial velocity, e1 is the initial kinetic energy, v2 is the final velocity, and e2 equals to half mv2 square is the final energy of electrons. So change in kinetic energy due to retardation will be half mv1 square minus half mv2 square, and it will appear in the form of radiation, and the energy of radiation is h into nu, where h is Planck's constant, nu is the frequency of the radiation. Now suppose that when will this energy be maximum? When will this right hand side will be maximum? Now suppose this value is 10, and if I will say this value is 4, then 10 minus 4 is 6. But when will this side will be maximum? When this side will be 0. That is 10 minus 0 will be equals to 10. This is only possible if electrons is suddenly stopped, that is v2 is equals to 0. Then take v1 equals to v, then we will get x-rays of maximum energy. Then above equation becomes half mv square equals to h nu maximum. Also electrons gain energy or move due to potential difference. Now therefore half mv square, that is kinetic energy, equals to ev, where E is charge on electron, v is the potential difference. More the potential difference, more will be the velocity, more will be the kinetic energy. Now comparing above equations, so h nu maximum equals to ev, or hc by lambda minimum equals to ev, because c equals to nu into lambda. So more the frequency, lesser will be the wavelength. So hc lambda minimum equals to ev. Therefore lambda minimum equals to hc by ev. H is Planck's constant, we can put the value. C is speed of light, put the value. E is charge of electron, put the value. Then you will get 12400 divided by V angstrom. It means that the wavelength of emitted X-rays will only depend upon the potential difference. This is known as Duane-Hunt law or limit. Duane-Hunt law or limit. If we will plot the graph between X-rays intensity and X-ray energy, so this will be the graph and this is the lambda minimum. So this graph is known as continuous curve. So my dear friends, I hope you have understood about the production of X-rays with the help of retardation of electrons. In the next lecture, in the next video lecture, I will discuss about the characteristic X-rays. So please subscribe and like our channel, and please continue to watch our channel. Thank you. Thanks a lot.